This is actually what I did on the stream the other day. Right here, Poisson disk generation. So I've technically already done the first step. Then make the points progressive. Giving a rank to each point. These next 3 steps are the actual hard part, in my opinion. You go through basically ranking the points by void and cluster. You basically have to sort every single... First of all, you have to do this really expensive energy calculation where you go across and you add up the energy of every nearby pixel. So you basically need to loop through every single pixel in the image for each pixel in the image. As far as I'm aware, there's no way getting around this. So yeah, it's going to be expensive, and that's why I'm implementing it in GLSL. So that's the other thing, is sorting in GLSL isn't like a super simple thing. So the other day, this was actually the reason why I implemented the merge sort on stream yesterday and optimized it, is so that this will give me my quick, efficient way of ranking the void and clusters by energy. Because if you see here, you give them ranks, find the tightest cluster and remove it. Rank the pixel you just removed is the number of ones left. So basically, you're going to have to sort a ton of pixels. So finding the tightest cluster is basically searching through and finding the smallest energy value here. Which is kind of expensive. So that's going to be the first part of the stream, is mostly going to be planning out how exactly are we going to implement this. Do I want to do it all in WebGL? Do I want to do, because this part right here, finding the tightest cluster and removing it, find the rank for the pixel. This seems like it would be best done on the CPU, actually, just in JavaScript, because you're basically going to be doing it one by one, remove the tightest cluster and record a rank for that. So in WebGL, that would be doing one pass per pixel, which would be pretty inefficient. That would probably actually be best on the CPU. This does basically the inverse. It finds the largest void and inserts one there. And then finally, phase 3 adds all the points until everything is made up of 1. And then finally, those ranks that you calculated is the pixel values. So it's a really expensive algorithm. That's why I'm very focused on optimizing it. As far as I'm aware, there's no online blue noise texture generator. Yeah, so I think there's no actual thing for generating blue noise right now online. It's all downloadable apps. So I think I'll actually be the first WebGL app or in-browser blue noise generator, which will be cool and also very useful. All right, so let me think about this. So this initial binary pattern, it does it here, finding the tightest voids and clusters. I'm just going to use this Poisson disk generation if possible, or Michelle's best candidate. You can actually see here So this article is great. The guy actually went through the optimizations he did. The one notable success was using Mitchell's best candidate to generate the initial binary pattern. I grabbed my go-to algorithm and gave it a shot. It is noticeably faster and seems to give decent results, but it also gives different results. So that's one of my things there, is if I want this to 100% match up, I probably want to actually copy this first step for the initial binary pattern and not use my own Poisson disk generation. How do you pronounce Poisson?
Poisson.
Poisson. Okay. All right. Find the largest cluster, remove one there, find the largest void, and put one there. You repeat this until the tightest cluster found in step 1 is the same as the largest void found in step 2. Phase 1 makes the initial binary pattern progressive by giving a rank. To give them ranks, you need to do this in a loop. Find the tightest cluster and remove it. The rank for that pixel you just removed is the number of ones in the binary pattern. So this is the other thing about doing it in WebGL. You need to keep track of the number of ones that are still in that binary pattern. You know what? Looking at this seems like something that's basically all going to be done on the CPU. I'm wondering if when you remove the tightest cluster, does it change what the next tightest cluster is? So you basically need to calculate these step by step. You can't just calculate all the ranks at once. Because I'm thinking once you remove the point of the tightest cluster, it'll change what the next tightest cluster is. Do this in a loop. Find the tightest cluster and remove it. So I can't, so what that makes me think is I can't just rank all of them and then remove them all at once. Phase 2 resets back to the normal binary pattern or the prototype. Finds the largest void and inserts one. So yeah, that's definitely going to change the next void, I think. Oh man, I should actually do a test for this, I guess. See, the thing is, if I do rank this, if I do all this in a batch in WebGL, I actually don't need to count the number. So you know what we're going to do? We're going to create a little test. First of all, we're going to set this up basically in JavaScript, and we're going to test finding the tightest cluster and the largest void, and we're going to see if removing either one changes the next tightest void or cluster. Oh yeah, I can't go to my desktop like this. All right, so we're going to create noise generator. All right, so since this is all going to be in HTML, at the beginning here, I don't give two shits about the styling. So it's basically just going to be a script. You know, I had a viewer the other day say that, like, he woke up after getting super hot in the car, he fell asleep, and after he woke up and sweating a bunch, he had trouble breathing. I don't know what it is, but I just woke up and I am definitely short on breath. I was outside in really warm weather the past 2 days. I don't know if my face is still all red, but it was stupid. It looked like I had a sunburn when I didn't even have a sunburn. So this JavaScript event, DOM content loaded, is where we will start running our code. This event is called when everything is loaded in, or at least all the document element stuff is loaded in, like these scripts. All right. So first things first, I'm going to copy this and let me look at his optimization of tabs. Lookup table. The best optimization I did was a lookup table for pixel energy float array, the same size as the output. Whenever I put a 1, I also added that pixel's energy into the energy lookup table for all the pixels. When removing a 1, I subtracted the pixel's energy from the lookup table for all pixels. Using a lookup table, finding the highest number is all it takes to find the tightest cluster, finding the lowest number. Okay, that's really smart. I'm probably going to copy that. Limiting to 3 sigma, have 99%. Decide to try only considering pixels within a 3 times sigma radius. While this tremendously sped up execution, it was a failure because pixels were blind to other pixels that were farther than 6 pixels away. Yeah, that makes sense. In the early stage of this, the existing sample points were pretty sparse, and you're trying to add points that are the most far apart. If the farthest you can away is 6 pixels, but your blue noise texture, yeah, that makes sense. Does a DFT on the binary sample pattern, multiplies each pixel by a frequency space representation of a Gaussian function of a required size, and then does an inverse DFT to get the result as if convolution had been done. This uses the convolution theorem to presumably get the lookup table made faster. That's really interesting. Multiplies each pixel by the frequency space representation of a Gaussian function. What? Frequency space representation of Gaussian function. Frequency. Taking the Fourier transform of a Gaussian function yields another Gaussian function. So in particular, fixed by the Fourier transform. This is fucking complicated. Oh my god. Alright, anyways, I'm going to look at So what this guy talked about with the exponential function declining after 3 99% of their value within +/-3. All right. I don't know what's happening here, but it definitely doesn't fade off at smaller than -3. All right, so if my ranking method doesn't work, then we can always use the lookup table method described here, and I can just do it all in JavaScript. But let's test it. Let's test this out. So first of all, we're going to generate our binary pattern. I'm just going to do it 4 by 4, so it's or 8 by 8, so it's as fast as possible at this point, just for testing. So to start out, you need to make a binary pattern that is the same size as your output image and has no more than half of the values being 1s. The code that goes with this post, I sent 1/10 of the values to 1s. After this, the initial noise. But they aren't progressive because they have no sense of ordering. Yeah, so I'm really thinking about using the Poisson disk pattern for this. I'm wondering if he's sending 1/10 of the values, is he just setting them in a grid order, or I guess I'm just going to try initializing them randomly. Like if math.random bigger than 8 has like a 20% chance of being on. That should, it'd be very unlucky to have more than a tenth of, or with this method it would be very unlucky to have more than a tenth of the pixels or a 20th of the pixels set, so that should be good. Alright, so now I'm going to find, or I'll create a function to find the largest void. Find largest void. Now this is going to be really expensive because it's going to have to search through every single thing. Yeah, so I think what I'm going to do is I'm going to actually sort this into an array. And then I can sort the array after this is done. So En is going to be energy. All right, this is going to be the hard part. Es is going to be the energy sum. So now we have to loop through all of the nearby pixels again. But I guess we have to skip this pixel itself. So Sx equals x and Sy equals y, then skip. Otherwise, add the energy. All right, so our energy equation is math exponent distance squared. The distance squared is just without the square root, right? It's Sx minus x, Sy minus y, then dx times dx plus dy times dy. I'm guessing. Let me make sure, because I suck at math and I need to make sure. Squared distance involves computing the square root. All right, yeah, awesome. So dx times dx, and then we need our sigma value, which results in different patterns, but I'm just going to set it to a constant of like 1.9 right now. Let's actually calculate this. 2 times 1.5 times 1.5, 4.5. 2 times 1.9 times 1.9, 7. Oh, that's actually way higher. All right, so I'll just try setting it to divided by 5 to start. And then, yeah, okay. So now we sum this energy, and that is our output. So that actually wasn't too hard. So there's our energy values. So now what I'm going to do is I'm going to sort it. Just using JavaScript sort, because I just want to test this. Wait, JavaScript sort typed array. Is there a sort function for typed array? Yes, there is. I'm assuming it sorts in place, right? Yeah, it sorts in place. Okay. So I can just call sort. That's awesome. So I should just be able to output this like that. All right, now we've got a bunch of energy values. 5, 7, 8. I guess it's the ones in the middle that have the most. I completely messed this up too. I'm supposed to check right here if this pixel I'm sampling even has something there. So if a index plus plus or v equals a index plus plus or v equals 0, then skip. And then if a x plus y times size equals 0, then skip. To mark that there's nothing here, we're going to set the energy to I think to mark that there's nothing here, I'll set it to -1. So anywhere there's -1, there's no particles. Oh, yeah, I forgot. It's an unsigned integer, so there's negative shows up as uint max. Is there a uint max constant? I guess not. I guess I just have to do, I think it's 2 to the power 31. Yeah. No, I guess it's 2 to the power 32 minus 1. Oh, so this is actually supposed to be a floating point array. Wasn't very smart of me. Okay. Here we go. So there's a whole bunch of points with nothing there. And here we've got all our energy values. So my question is, if I removed this void, would this 51 still be the most, the lowest? And you know what? This sort actually doesn't work because it doesn't keep indices. So you know what? I'm actually going to loop through and find the lowest and second lowest manually. And I'm going to set this to a really high number. So that way this shows up as the highest. Oh man, actually, yeah, this is difficult, keeping those out of the equation. So if V is smaller than low, then S low becomes low and low becomes V. If V is smaller than S low becomes V. And we also store the index of those. So slow I becomes low I becomes I. Slow I becomes I here. All right. All right. First void. second void. Okay. So now that'll tell me the first void and the second void is actually at 0. That's really interesting. Actually, it makes sense if you think about it, because it'll be at the corner and farthest away from other pixels. Maybe I should apply wrapping so it's tileable, and because I think wrapping might change the result of this. Anyways, let's look at it. Yeah, so the voids are more likely to be these 0 points. So maybe I should do this relative. Whatever, let's just do this test first. So we're trying to see if that when we remove this first void, if the second void stays the same, because that means that we could just sort this whole energy array and just use those sorted numbers as the ranks instead of doing it one by one, which would be a lot slower. So what we're going to do now that we've output the first and the second, we're going to run the energy calculation again, and then we're going to output. So this outputs the lowest, is what this does. So now we're going to call that twice. And we're going to see if the second void from the first time becomes the first void the second time. And it's exactly the same because I'm an idiot and I didn't actually remove any. That's smart. That's really smart. Okay. So what I'm supposed to do here is in my array to pass in the binary pattern. So in this part, I need to set the binary pattern lowest index to 0 and remove it like that. So now it should output 2 different results. What is there's an option to not repeat the same things. I don't know. Anyways, let's just run it. First void at 58 and second void. Oh my god, it's the same void, 62. Oh, if we're going to be able to optimize this, that's going to be amazing. Okay, let's run this recursively. Let's see. I want to see if this holds true for multiple things, because it should be random, so I think it's just luck until you have a void that it's just going to be a chance until you have a void that doesn't match up. So first void 58, second void 7. 7 matches up, second void is 13, matches up, second void is 44, it matches up, 47, it matches up, 46, it matches up, 8, it matches up, 2, it doesn't match up. Okay, so that's what I thought. So this second void is 32, but then it calculates it as 43. Okay, so yeah, you can't optimize this by ordering it. Oh my god, this is going to be a really slow algorithm. Oh my god, this is going to be a really slow algorithm. Holy crap. So you need to literally do this brute force step by step. Jesus. All right. So there goes all my GLSL optimizations that I thought I was going to do. Just out the window, because you actually need to do this pixel by pixel and remove them step by step. That's okay, though. That's okay. So I'm going to do this in JavaScript. I'm going to do it with the lookup table optimization he discussed here. Let's do it. So I'm going to create a little UI for this to begin. Basically, I just need a, first of all, I'll add a title. That's the first thing I should add. And then I need a style. So all this is going to be, because it's going to be a thing that's like blue noise. You know what? Should I make a multi-dimensional version of this? No, I guess 2D is. The problem is blue noise volume textures don't have the same properties, and it's actually best, at least if you're doing ray tracing or something, to actually use layers of 2D blue noise textures. It's really interesting. There's not a lot of use cases for blue noise volumes. Alright, so I'm going to create an input. So this will be the size. Then there's also going to be an option for the sigma. I should also set the default values for this. Default size to like 16 while I'm testing. Default sigma of like 1.5. Add some styling here. First of all, we'll align everything to the center. I'm going to give it a dark theme. It's like dark gray background. I'm going to use monospace font, and I'm going to increase the font size to like 20 pixels. Blue noise image generator. All right. And I'm actually going to copy some style I have from the Marbles and browser here, because I actually really like the simple link styling I have right here. I'm just going to copy this for the A. And then down here at the bottom, below all the stuff, man, actually, how do I do this? Do I do it in a generated canvas? Yeah, I should probably output it to a canvas. Wait, let's see. JavaScript image set pixels. Can I set the pixels to an image? Oh yeah, okay, so using canvas. Name it display for D. Actually, I don't even need an ID, I don't think, because it's canvas, so I can basically just search for any canvas elements in the page. I'm just wondering too, did I even put copyright right here? No, I didn't. I should put a 2019 right here. Man, copyright sounds so much worse than created by. While I'm thinking about this, though, I should change this right here. Created by copyright 2019. Okay. So there we go. Now right here in this canvas, when it generates the blue noise image, people will just be able to click Save Image. Alright, so now I need a button for generating it. I want to see something that I haven't checked before. HTML input button versus button element. What's the difference between them? HTML into button. Why people avoid button. Okay. So yeah, that's kind of what I thought is input type button is the original. And it's more simple because you just use value. And then I'm actually going to put a little span beside here. For the generation message, so that'll give a little message while it's generating. Like just as a test, I actually want to do 0%. Yeah, so that looks decent. All right. All right, so that's all the UI set up. Now we just need to do the actual generation. So the first thing I'm going to do is I'm going to set up all this stuff. So I need to attach an event listener to this generate button. I mean, this is the same shortcut I use in Marbles in browser where I just create a shortcut function for getting the document element by ID. So then I can just do like this. And actually, I want to design this with closure from the beginning. This is something I didn't do with Marbles in browser. And then I felt kind of stupid when I spent like an hour trying to get this figured out. All right, awesome. So now in our generate function, the first thing I need to do is I need to check if this is even supported for people, because there's still some people that will be on old browsers that don't support uint8 array. Okay, let's just test this now. Browser is not supported, please. Yeah, okay. You should check it out. I don't know, when someone comes in chat and the first thing they do is tell me to check something out and post a link, I think that they're basically just trying to advertise. I don't let links posted in my Twitch chat. You can post them in Discord if you want. Cooper, are you like English? Is English your first language? Okay, you can really tell. I am not sure how I want to implement this now. I guess I'll just copy this lookup table method. I'm going to start by just generating the binary pattern and just outputting that, I think, just so that I even know the canvas works, because I haven't even tested outputting to this canvas yet. So, new binary pattern. I should have kept my code from before for generating that, but oh man, that other method actually wouldn't have worked perfectly because it was random. It could have got unlucky and sampled more than half of the pixels. So what I should do is sample a grid, a uniform grid with offset points, so that it's random, but it's still guaranteed to not be more than half the pixels set, because there's the key part, where does he say it? Right here, no more than half the values being ones. That's the key part right there. So bin is going to be our binary pattern. We're going to store the size as width. T size is going to be the total size. So first of all, we'll load this in. I guess I'm going to need IDs for this. I don't know if I'm probably going to need to call parse int or float on this as well. So the sigma is going to be a float. And now I also got to check if these are valid values. Like I have to check if the float is not a number, which I don't think actually returns true for infinity. Let me check. Infinity. Okay, I guess I have to do 1 divided by 0. So is not a number doesn't return true for infinity. That's okay. I guess I have to do is infinity separate. Wait, what was that actual function? There's is. Oh, is finite. I'm just going to automatically, I'm not even going to give warnings here. Just thinking about it, I'm actually just going to clamp to certain values. So like if width is smaller than 2 or width is bigger than, well, I guess there's no limit. I'm going to limit it to 2 and I'll limit the sigma to 1.5. And then this message element, I'll just generate the binary pattern first. Did you check the link? No, when you post a link in a chat where the link is removed, no one can view the link. So the total size is the square width. Sad. Well, see, if I spent my whole stream just clicking other people's links, I wouldn't get anything done. All right, so to generate this binary pattern, I'm going to treat it as a grid. So wait, is there JavaScript set typed array to 0? Default values is 0. Okay. Oh, there's a fill. Fills the elements from start index with static value. Awesome. Okay. So it's already initialized to 0. G width is going to be the grid points, which is going to be width divided by if there's a point every 4x4, that's every 16 pixels, so that's 1 out of 16 pixels set. In this article, the guy Alan set them to 1/10 of the values, so I guess that would be like 9, which would be every 3. So I'll do that. So you know what I can just do here? I can just do plus equals 3. Okay, and then, yeah, the difficult part here is going to be the random offset. So this I can just do times this equals 1. The one thing I don't know how to do is setting the image data for this canvas. I think it's, yeah, put image data. Is there an example of how to do it? Put image data. Data equals image data dot data. Get image data. Okay. All right. I think I know how to do this. So first of all, get the canvas element, which is D. Do I need to get the context for this, the 2D context? Oh yeah, okay, I need to get the 2D. All right, Cooper, I will look at it after the stream. So I need to set the width and height to the actual image size. Now I can get the context and the image data. And we just want to get all of the image data. So now we go through and we assign our binary pattern to the image data. And then we put the image data, and it should work. BIND is going to be the binary index. PIND is going to be the image data index. I'm not sure. Does it do alpha first? No, so it does alpha last. Okay. So image data pixel index equals, need to load in our binary value. So binary index plus plus, multiply it by 255 because it'll be 1, so this will be 255 for on. And then I want alpha to be constant 255. Then we should just be able to put the image data back like this. Put image data dx dy. Okay. All right, so that should output a grid of points. No, it didn't. Inspect element. Oh, it didn't even initial. Oh, wait, I'm an idiot. Generate. Canvas. All right, so the canvas is initialized, but didn't set the image data. So maybe I messed something up. Let's try just setting everything to 255. That didn't work either. All right, so something is going wrong here. Let's look. Let's look at this example. Draw content on the canvas. The only thing I'm not doing first is drawing the context. So that could explain oh, it's image data dot data to get the pixels. Oh, okay. So pixels is image dot data. And then I assign this, I assign the pixels. Here we go, okay. So that's what I want. Generate a white square. Now this should generate a grid of points. Yeah, awesome. Here we go. All right, now we're getting into this. Now we want to randomly jitter those points. So that's this initialization right here. Basically, we want to jitter this x and y. So I guess I could just do plus math.random times 2 minus 1 times 2 minus 1, and then floor that. And clamp it as well. Or actually, if I start this out at 1, it probably won't overwrite. Let me actually check this. Our index equals that. I'm going to check if index bigger or equal total size. Shit. No, we're good. All right. So now, just to I'm going to start bringing these into paint.net so I can actually zoom in and see what's going on. All right. So one of the things we can see though is our points are way more biased to one side than the other. I think that's an issue. I'm going to create this a bit bigger. But yeah, you can see. So this also makes me wonder if it's more biased to that side, that would explain why it's not going over the index, but maybe it's going under the index. No, it's not. All right. So let's think about what's happening here. That for whatever reason, it's not going all the way right here. I believe it's because of the plus equals 3. But I'm not sure. Times 2 minus 1. Maybe I gotta do like times 3 minus 1 so it's biased towards. No. Let me look at this with no warping. Does it have that issue? No, it doesn't. It's completely aligned. Okay. So I know what I need to do then. I just keep this, what I'm doing here. Change this to 0. Now this will probably end up, yeah, shit, -1, shit, negative. Yeah, that's what I thought. So now I need to add a clamp to it. But you can see now it's more biased on this side than that side. So I believe adding the clamp here will balance out that bias. The thing with JavaScript is, though, there's no clamp, so I have to use min-max. So minimum of width minus 1, maximum of 0. I think there's an error with my code. Yeah, there is. Unexpected syntax error. Random. Yeah, so I need a lot more parentheses here. 5. 4. Let's split this into new lines. Min, max, floor. 1, 2, 3. 2, 1, 0. 1, 2, 3. 2, 1, 0. All right. There we go. Awesome. Okay, so here's our prototype binary pattern. It's basically a jittered grid. I'm hoping this works. Actually, this isn't the prototype binary pattern. This is the initialization pattern. I lied. We still need to generate the initial binary pattern. Find the tightest cluster, remove the 1, find the largest void, and put the 1 there. So we're going to use this lookup table method of storing a table of all the pixels values. So we're going to create an array called energy. What is this for? Is it just for fun? It's for generating blue noise textures. Blue noise textures have huge benefits for sampling and a whole bunch of stuff. At the beginning of this, I showed this article. Not all blue noise is created equal. It basically went over how different blue noise methods, void and cluster, which is what I'm trying to implement, filtering white noise, which is the easiest way, but it creates low quality. So this is the thing, there's blue noise, and then there's like perfect blue noise that gives you amazing dithering, and that's what this void and cluster does. There's like just regular blue noise that you get from Poisson disk pattern. What's the point? It's really hard to explain. Let me just show you this dithering. Here, this dithering test is probably... Alright, so you've got a grayscale thing like this. Like, say you're trying to compress data, so you're quantizing it to a bunch of discrete... So this would be the equivalent of like 4-bit color right here, instead of 8-bit. So then what if you want to smooth it back out by dithering? You can do regular white noise, which is like, I have some regular white noise, right? Do I? Noise dither 0. So you can see here with white noise, it looks really noisy. It's probably hard to see on stream, but then if this is a gray noise texture, then if you use blue noise, what am I doing? Noise dither 0, UV. Oh, this is supposed to be frag chord, I think. I'm confused. This isn't returning the right value. One sec, let me rewrite this. Vec2 p x times 2 minus 1. All right, here we go. So it's hard to see, but this blue noise texture looks way smoother than the white noise. And that's basically what blue noise does. It's really complicated, but long story short, because it's high frequency noise, your eyes pay attention to high frequency noise a lot less, and it can easily be filtered out with a low pass. Like if you blur this blue noise, it smooths out a million times better than white noise. Because if you know what a low pass is, a low pass cuts out high frequency components. So if you're using blue noise where all of your noise is going to be high frequency, doing that low pass is essentially denoising and cutting out the noise. Another test, another example, you can actually see it with this noise convergence test. So on the bottom, we've got our blue noise, and on the top, we've got the white noise. Right away, at like 5-10 samples, you can see that at the bottom end here, the blue noise looks way better with less samples than the white noise. You'll see though, as you run it, at the end here, you can see that the white noise and the blue noise basically become equal when you have tons of samples. But when you're doing lower samples, you can see here the blue noise is basically like twice as good. It looks way smoother. So if you're doing a path tracer like my marbles game and you're trying to reduce this noise here, blue noise is like the ultimate. But then I was having a whole conversation with people in the Shader Toy Discord about this the other day, but then there's like non-noisy patterns like this that's a uniform sampling pattern. And watch it. Because it's uniform, it converges way quicker than any of the noise because it's actually uniformly sampling. So it's really like, it's such an interesting field, just like sampling. But yeah, long story short, blue noise patterns. Also, this webcam thing I'm using right here, if you notice, I've got noise dithering here on the edges to like smooth out the sides of the pixels so it's not blocky anymore. And I'm going to use blue noise to dither that because it's way better dithering. So yeah, basically blue noise, tons of uses. It's really hard to generate, which is basically the reason why I want to generate it. I like doing difficult things. But yeah, it's half of, I actually need a blue noise texture and another half of, it's a mix of things. I haven't done this before. I want a blue noise texture. I want to understand how it works. And also it's something that, as far as I'm aware, there's no in-browser blue noise textures right now. So like, that would be pretty cool if my website had the only blue noise in-browser blue noise generator. Anyways, now that we generated our initial binary pattern, we can go ahead and begin with the first step. And that is, in a loop, find the tightest cluster, remove the one, find the largest void, and put one there. Repeat this until the tightest cluster found in step 1 is the largest void found in step 2. Okay. So I'm going to comment out this part of the code that just output the image for debugging. I'm going to create a quick function for progress that basically outputs the value of the progress. So our M element is the text element for storing the progress. So I'm going to do like V should be a value from 0 to 100, 100 being 100% done. So percent done. That. So once this starts running, I'll set progress to 0. Because this initial binary pattern is such a complicated part, I'll just set the progress to 1 right here. Generate it, 1% done. Okay. So now, because this is going to be so computationally intensive, I'm going to put this into a timeout loop. So it basically gives the browser time to work on other things. What am I going to call it? What should I call it? I guess step 1. All right. So the other thing I'm wondering is, I think even on this initial pattern, I can apply the lookup table optimization. So actually straight away here, I'm going to initialize the energy. So it's going to be a float 32 array. I'm not sure if I should initialize it to 0. So this is the other thing, is technically speaking, because this has to loop through everything multiple times, this might freeze people's browsers on bigger processes. So I may actually want to use web workers for this now that I think about it. I don't know why I wouldn't do this with web workers. I'm an idiot. Okay, let's create a web worker. What is a web worker? When executing scripts in an HTML page, the page becomes unresponsive until the script is finished. Yep, so if you have a script like mine that's going to take like an hour, you basically need a web worker. It's a JavaScript that runs in the background independently of other scripts without affecting the performance of the page. You can do whatever you want while the web worker runs in the background. It runs on a different, what it doesn't mention as well is it actually runs on a separate thread, which also makes it run way faster. Oh, so this is, so I also have to check the workers defined. Wait, should I actually use type of, let me check JavaScript. How do you check in JavaScript? Check if supported. Implementing feature detection. Navigator. So they just used in and does not equal undefined. Whatever. Let's just try setting up a web worker. Create your web worker file. Just call it work.js. Weird champ. Do it. Wait, I can't see BTTV on here. Do I have weird champ enabled? I don't think I do. Important part above is the Postmessage method, which is used to post a message back to the HTML page. Man, I haven't used web workers for a while. W equals new worker on message. Full web worker code. Let's look at this. Yes, you do. Oh, okay. Vanilla JS Andy. Yeah. Oh, so there's no web worker start. It just starts the web worker as soon as you run it. All right, that's okay. I'm just thinking though, I think yeah, you have to allocate all of your code in the web, or you need to allocate all the things you use in the web worker. Why are you not using Sublime with Sublime packages? I use gedit because it's super lightweight. It's like 30 megabytes and it runs super fast. And like, look at how little RAM it uses. 24 megabytes of RAM. For like Visual Studio, it uses like 500 megabytes. I just use gedit because I'm used to it as well. All right, I gotta take all of this away, comment out all this old code because I'm not gonna be using it anymore. And I actually think now all this binary pattern and everything, I'm actually gonna generate in the web worker. So wait, how do I pass data to the web worker? Because this just includes, wait, JavaScript pass data to web worker. How do I pass arguments? Oh, you can post messages back to the worker. Okay. Maybe the data has to be a string. Okay, let's look at the docs for this. Worker docs, Firefox. Message. This will be maybe any value or JavaScript object handled by the structured clone. Okay, so yeah, it only supports things that can go through JSON. Good to see someone isn't using trash Chrome. I use Firefox. Yeah, I've used Firefox for the past few years. Chrome has had some issues, especially if you watch Twitch. Like, I don't know if anyone else has this, but I actually can't watch Twitch on Chrome. It's like, it goes black screen all the time. So I guess what I'm going to do here is I'm just going to create my worker, and then I'm just going to call a set timeout and check if it's done. Or actually, I don't even need to do that because it's going to post a message. I have the opposite issue. Chrome works the best for me. Who knows what's even happening? New worker, work.js, worker.add event listener, message, function. How does this work? You have to disable cache on Chrome. I tried using the Twitch dedicated app. It uses my CPU to do decoding instead of the GPU, so I can't use it. Huh. I think it uses the CPU anyways on your web browser. That's stupid though if it does. It's not. I want to see that. Does Firefox is video playback hardware accelerated? And Destructor, are you sure it's not just like mining bitcoins or something? Decoding on GPU or CPU. Yeah, I don't think there's going to be much info on this. Video decode acceleration. Any video on Firefox will use the CPU to render it. Firefox uses CPU to decode video. No, you're right. Hardware video acceleration makes it possible for the video card to decode and encode video. Man, gotta love Arch Linux. Acceleration API is a specific API developed by Intel. Cool. All of it's specific to NVIDIA and Intel stuff, though. Yeah, it has all the H.265 options. That's really cool. If there were more games that ran well on Linux, I'd probably be using it. Not even the games that don't run for me, it's the NVIDIA drivers. Handle message from worker, message received. Let's set up a quick web worker test. And wait, oh yeah, crap. So if this is in the worker, then I'm going to need to call this progress update to update on the progress. Okay. All right. So how am I going to do this? To begin, I don't even know how to use web workers yet. So let's just write a quick test. Call this every 5 seconds. We'll post a message back that says testing. That should work, right? Worker code on message self.postmessage. I really like Linux. I'm glad I get to use it on my server. I really like Linux too. I guess I didn't save this or something because it's not running. Two, three, four, five. What's the message event object? Message.data. Okay. Oh. Alright. post message, it just posts an object. It looks like post message. Yeah, it just posts an object. Okay. I always dot data, gotta give them credit that they're consistent. Yep. Message received, testing. All right, we've got a web worker set up. All right, so I actually wasn't thinking about using web workers for this from the beginning. So now I kind of have to replan in my head how I'm actually doing this. So let's not keep that up. I don't know why Windows, after the recent update, sometimes you'll like scroll over this and go away, and it just keeps this window up down here. It annoys the heck out of me. I don't know why it doesn't go away sometimes now. You see this? You see this? Oh my god. Windows, man. Stuff like that. Like, it's all the little things like that that make me like Linux or Ubuntu. I actually, oh man, I've still been meaning to try Arch Linux. All right, let's program this now. So I can just run this web worker code in a giant loop and it doesn't pause the browser, right? Self.postMessage done. Oh, it's not pausing the browser or anything. Hell yeah. Awesome. Okay. So I can just use web workers to process all the data I want. I don't need to worry about the browser pausing. So this means I can set up this message event listener. Then I can post a message of the data. Post the width. And I can post the sigma. Wait though. Huh. Will this worker.js work with Clojure? With the Clojure compiler? Let me test something. I need to test if I don't know if Google Clojure compiler will keep the message data. Log message dot data dot var name. So basically what I want to watch for is if it renames data and var name or self. Self.onMessage a.data.a. Yeah, so it renames the var name to a. Oof. Property var name never defined on message.data. Oof. Okay. How am I going to work around this? I could just pass all the data in as an array, right? Yeah, so if I pass it in as an array, and it optimizes out this test variable. All right. So I'm going to do this with arrays just so that it doesn't break the closure compiler. This is why I use my Mac for dev, can't deal with that shit. Nah, just use Linux. I have never used a Mac, like for actual work. Like I've gone on a Mac and I've just been like, nah, this is too different. All right, so here I'm going to pass an array instead of an object. And actually, I need to make sure that this on message is set up. I can't do alerts from here, right? I don't think so. All right, so the first part of this post message is actually going to be, it's just going to be the data actually. It's going to be this that needs to check the message data. All right, so this first message, we'll just load in the width and sigma. Look at that. Then we're going to initialize the binary and energy pattern. So that's the same code that we had right here. We're just going to do it in the web worker. All right, so binary equals uint8 array. Tabs or spaces? Tabs. Let's see what do I have gedit set to? Tabs and 4 width. All right, so we'll initialize the binary pattern here. Then we'll initialize the energy float32 array. We will calculate the initial values of this energy array. And this is going to be really expensive because it's going to have to loop through all the nearby pixels. Oh, I just also realized it uses math.random, which is non-deterministic, so it'll give different results each time. I'm not sure if that's good or bad. Run, context is separated. You can run whatever code. For example, you can't directly manipulate the DOM or use some methods. So I can still use random. You know what? I don't care if this is deterministic or not. Oh, wait. Actually, I do. Because there's probably going to be situations where you want to see the same texture but with a different sigma. So yeah, I'm actually going to add an option for the seed. And then I'll initialize the seed with a random value when the match starts. All right, so now just need to check if it's not a number, not infinity. Then we'll set the seed to 0. All right, so now we'll also pass the seed in here. And I'm going to take my random generation function from marbles. Where is it? RNG S? Yeah, right here. Okay, so we'll take that. And in the web worker, I'm going to change this so that it doesn't take in a seed. It just uses the same seed value here, like this. All right. So now instead of math.random, you just do RNG. So I'm curious as well if this changes the pattern or makes it less random. This would actually be a good test for my random generation. Maybe I will output this binary pattern just to begin. So I'm just going to do self.postMessage binary pattern. Can't decide what I want to work on today. I just kind of do things as they flow. It's like I'm making a marble path traced game, and then I'm like, okay, I want blue noise now to make sure it looks the best it can be, so I guess I'm doing blue noise. And I did that like a week ago, and now I still haven't got blue noise, so yeah. Seed equals message 2. So I'm thinking this message, I should probably add a little thing like the binary. Trello how to pick a random card. Does it not? I haven't used Trello for a while, but if it's JavaScript, maybe your project should be making an add-on for Trello that picks a random card. Project is in Unity. Yeah, but you can always switch it up. Bin equals message.data. Something went wrong. Let me output this to the console. Wait, what the hell? The uint data array is empty. What? Can you not pass a uint8 array? Oh, this is supposed to be message.data. Not smart of me. I want to test something as well. I want to keep testing closure compiler. With the advanced, I haven't used the advanced option in this very much, so I'm still not sure exactly what it does. I want to see if it will rename these variables right here, even though they're not wrapped in closure. It makes me think it will. Yes, it still renames them. Awesome. Sweet. Okay. So as far as I can tell, that keeps all of the names. Does the closure compiler just obfuscate your code? It also optimizes it and removes unneeded parts. Like it's pretty crazy some of the stuff it does. Like I don't know, it's really hard to read and actually explain what it does. But yeah, basically when you're doing web pages, so I don't know if you know, but Google ranks pages that load faster, or Google is supposed to rank pages that load faster higher up in the search. So they've created a bunch of tools like Closure Compiler that are designed to make your web page load faster by optimizing JavaScript and reducing, it's not necessarily obfuscating it, but minifying it so that it takes the least amount of space when you're loading the web page. But minifying goes along with obfuscating, so. But it is obfuscating it by doing that. Yes, it is. And I'm going to be honest, I do not care if my code's obfuscated. I like giving people a challenge. It'll make it harder for them to reverse engineer, but I'm just going to release this on Bitbucket anyways, so if you want to know what's happening in the code, just make sure you keep the original somewhere. Yeah, so you'll see I have my marbles in browser code right here, main.js, and then main min.js right here is the obfuscated. So yeah, I always keep, what I do is I just name it min. You'll actually notice this if you look at what a lot of web pages do this is they add the -min. Like if you download JavaScript libraries, you normally get two versions. You get the original source and then you get the minified. Yeah, it is the common way. So if I really want people to read my code too, I'm going to post this on Bitbucket or wherever so people can just read the code. Recently, though, I've actually not even been posting on Git or Bitbucket. I just post the source code in a zip file, and if people want to download the zip file and look at the source, then go for it. I wonder if it's bad to do copyright Ethan Alexander Schulman when this isn't even my algorithm. Git may be easier. Yeah, it is more easier. That's almost what I don't like about it. I kind of want it to be more difficult for people to get access to my code. Like, I feel like if you can't be bothered to download a zip file to look at my code, you're probably also going to be the type of person who's not going to bother to even give me credit. So, yeah. Like, just as an example, so just, this isn't actually an example of that exact thing, but, so if you go to my YouTube here, I got this creating a text generating neural network, right? First link right in the YouTube description is a Bitbucket to the neural network library. Has all the code here. Literally all the code, all the examples. Guess what one of the fucking comments is? Where is it? There's people literally asking me, is the library open source? When the first fucking link in it is a link to the library's source. Holy shit. Fucking people, man. Yeah, I know, you can't help that, but like my whole thing is, even if you make a super easy way for people to access it like Bitbucket, there's still people that are like it's still too hard for a bunch of people. So even the easiest way, that's why I kind of think a zip file is just the best. Also, Bitbucket and GitHub don't normally give a direct zip download of the whole source. I just meant that someone could run a search on Bitbucket for those terms and find your project a bunch easier. Yeah. Actually, I don't think Bitbucket works like that on GitHub. Bitbucket's more private. Bitbucket's designed for like private teams. Maybe there is Bitbucket public search. Search public repositories on Bitbucket. Search feature does not search public repositories. Yeah. Like Bitbucket's a premium one. It's not really for like public stuff like GitHub. It's more for like private team projects. Anyways, I'm very happy to have this web worker working. So now, boom, we generated our pattern in web workers. Hell yeah, we're learning something today. Holy crap, this thing is happening over and over again where it's not going away. Jesus. Windows did something in the last update with the taskbar, it seems like. Alright, let's get back to writing this code. So, next step is to calculate the levels. Keep in mind, I'm not trying to tell you what to do, I just know that people do search GitHub for terms and look for projects. Oh yeah, I know. Thank you for your suggestions, though. I don't mind having people telling me what to do because it makes me find out new things that I never realized before. This specific page might be easy to find, though, since you'll be the only one. Yeah, I think C# neural network library. It used to be one of the first ones on Google. I guess it's not now. I gotta say, Google seems like it's a lot worse now. It doesn't find even close to as many search results as it did before. Wait, what about DuckDuckGo? Yeah, so it gives different results. That's actually nice. Has a bunch of actual code. I swear to God, Google is a lot worse now. Like, how do you even prove that Google has gotten worse? It's not like people have like it's thousands and millions of search results. So how do you even prove if Google's recommendations or search got worse? My main thing is that the YouTube recommendations have, if you were in the Discord, you saw the link I posted about like an ex-YouTube employee actually talking about how the algorithms to recommend things on YouTube are like, basically they didn't realize a whole bunch of things about the algorithms they implemented. And my whole question with this is, why couldn't they just use the old recommendation algorithms that worked great? Like, there were so many years where no one complained about recommendation algorithms or anything because they just worked. All right, UEN is going to update the energy. Does brute force calculate the new energy values? SV equals 0, then skip it. Otherwise, we'll calculate the energy value. And that is brute force searching through all of the other points. And this is why I have to put it in web workers, is so it doesn't freeze your browser when it does this. So I need to check two things. First of all, if this point is equal to the current point, then we skip it. Or if there's no point here. So if the binary pattern is equal to 0, then we skip. Otherwise, we add. Our energy equation is the negative distance squared. Okay, so distance squared is dx s minus sx, y minus sy, dx times dx plus dy times dy, times negative sigma. So we're actually going to pre-compute the sigma value here, which is, so instead of doing divide, we can just do this as a multiply. So it's going to be -1 divided by the 2 times tau sigma 2. All right, so that takes, oh wait, I did that to the seed instead of the sigma. Oops. We'll just swap these around and name this seed. So let me make sure that this is the same. Divided by 2 times sigma to the power of 2, 2 times sigma to the power of 2, and that's divided by negative. So that does all the negative and divided by in a single multiplication. All right, so it's pretty good. It's pretty well optimized. Energy. I just realized I need to only increment this variable at specific points. Energy equals energy value. All right. So now we calculate our energy values. Reen. I'm actually going to name this to Reen, which is recompute energy values. I'm kind of on the edge on whether or not I want to release the source of this. If I do, I should probably comment it. Initialize options. Compute initial binary pattern. Or generate 1/9 of points. To 1. Compute cluster energy. I'm going to do a link to this article. Whoa, 0 dropped frames. Oh my god. Wait. I've had the webcam off this whole time. Shit. Huh. Alright. Sorry, I thought you were doing it on purpose. I was doing it on purpose yesterday, so yeah, I understand you thinking that. That's on me. Zero drop frames is pretty cool. It's weird. It doesn't make any sense. Some days there's no dropped frames. Yeah. I'm not even trying to understand the dropped frames anymore because it just seems to be out of my control. Alright, let's look at this again. So find the tightest cluster and remove one, find the largest void and put one there. So generate initial binary pattern. So I guess I need to loop through these energy values. And then find out which values are even set. Same size, has no more values being 1. I set 1/10 the values to 1s, then in a loop, find the tightest cluster and remove the 1, find the largest void and put 1 there. Oh. So you initialize, to find the largest void, you must have to initialize even the 0 pixels as energy. Wait, do you include the pixel itself in the calculation? I think you do. Looking at how much energy, we use this formula, so this would be 0. What's math exponent 0? Is it 1 or is it 2.7? I think it's 1, okay. That's what I thought. So actually, yeah, we don't need this check there, I think. We just need if TV equals 0, skip. All right. And we loop through all of the points. This is going to be something that's actually while true. It just has to execute until it's done. MIV is going to be the min value. MII is going to be the min index. MAV is going to be the max value. MAI is going to be the max index. V equals energy I. If V smaller than min, then V equals V. If V bigger than max, max V equals V. It's I. All right, so now that finds the emptiest void. I wish I could style my UI stuff in Unity like you can in HTML with CSS. I think there's like add-ons for that. Like there's definitely code you can get that does that, but it's a lot less efficient as far as I'm aware, because anytime you're updating text or anything, it has to do a whole bunch of extra parsing. Like it basically has to look through and compare it to HTML elements. So it's kind of like a trade-off. Yeah, I'm commenting this, so I guess I'm going to release the source. I'm just going to change copyright to created. I don't know. There's a company that put Windows... Wait, what's WPF? Is that like Windows something forms? They want money if you make a certain amount. Oh, yeah. It seems weird to me, though, if I had copyright right here and then I had download the source right there. Windows Presentation Foundation. Oh. It's basically the Windows Forms replacement. Oh, okay. Windows Forms sucks. I don't know if you remember the stream where I did this overlay. Wait, does that cut off my camera when I put it off screen? No, it doesn't. So this is my overlay right here. And like Windows Forms has so many fucking issues. Like, holy shit, I cannot even begin to describe them. Like sometimes I will start this up and it just doesn't draw my text. Like sometimes I run this and it's supposed to draw like actually watch. When I put hi in here, it'll draw. And sometimes it just doesn't do it. Like I literally run the code and I see that it's setting the text to that. And then Windows Forms doesn't actually render or update the text. And there's supposed to be, what's supposed to happen is there's supposed to be this invalidate function that basically says the screen is supposed to be re-rendered, and it does nothing. You literally call invalidate, and it doesn't render anything fresh. It's the stupid, I do not understand Windows Forms, and that's why I don't use it anymore. It's ridiculous. Basically, Windows Forms just seems way too complicated for me. Just do a simple thing like rendering text. Alright, when tightest clusters equal, remove point, set 0 at tightest cluster, and I'm going to actually name these re-energy. Actually, why am I obsessing over the names of variables when WPF gives you the ability to do data binding, which I love. Just data binding. System way to present and interact with data. Elements can be bound to data from a variety of data sources in the form of common language runtime and XML. Isn't this just like Unity's thing where it directly assigns the value of the UI element to a class? Or am I misunderstanding this? It basically just automatically copies the value of your UI to a class, right? Isn't that kind of what Unity does too with its components? Unity doesn't do data binding for your data. Like, what would it be like if Unity did data binding then? Because, I mean, like, if you create a string, what it is if I update, say, player's money, data binding would refresh the UI for me. Unity does refresh it for you, doesn't it? No? Huh, it does for me in Unity. I have to set the text element yourself. You know that do you know about get and set methods in C#? Because if you override the get or set method, you can just set the text element whatever it sets. And then if you want like a text, if you want like a money number, that always updates, you can create like a custom class for the money that overrides float or whatever, or int or whatever you're using, and then anytime it's set, you can update. Like you can do data binding in C manually if you write the code yourself, or C#. It's not something I think you need. Some people don't like that design philosophy. Well, yeah, that's why C# makes it optional. Putting UI update code in the setter. Well, that's exactly what WPF is doing behind the scenes if it's updating it. Because the other alternative is like updating at a constant rate, like every 10 ticks or whatever, like every second. And that's way less efficient if you have thousands of elements that it has to check. No, what it is doing is the setter fires off a property changed event, and WPF is listening for those events. Isn't that like literally the same thing? Like it's just going through an event instead of directly calling the UI? All right, set 0 at the tightest cluster. And set 1 at the emptiest void. But you don't have to write text all over the place. The code is written once and centralized in this one spot. Yeah, wouldn't that be the same? Like, couldn't you just do that by writing a class to do it, though? So, like, you write your function in the class and you write it once, and then you just use that class everywhere else, and it keeps calling the same code. Compute energy values. Fresh energy values. Update energy values. How do I want to do this? Do I want to create one function for removing and one function for adding? Add energy at index, or actually xy. I guess I can just do index. Add energy, my I, remove energy, mai. I really want to design a cheat console. You don't really need a console for cheats. You can just kind of change values. so first of all, I got to convert the index to x and y. So that's index divided by width. Index minus iy times width. All right. We copy this. And we subtract. We also need our b iterator. So all we do here is actually subtract the energy so that would be x minus ix, y minus iy, and then it's basically just writing this exact same code here. So add the energy. All right, that's easy. And now we need to do the same for removing energy values after removing one. All right, I'm actually really curious if this is working, so I'm going to post the message after this. And have it output the pattern because I want to see if it's actually generating a blue noise pattern. I'm a very skeptical person. I also feel like this is going to take a really long time, but yeah, whatever. Yeah, it is taking a really long time. Who would have thought? I mean, it is doing while true. Maybe it's never finishing. If bin type of uint8 array. Otherwise, we're just going to output the progress. Wait, how do you use type of? JavaScript compare type. If type of bin equals uint8 array. I hate checking types in JavaScript, but okay, I think it loops forever. I'm actually really happy with this because this means It should have finished at 256, so I think it's safe to say that it's broken. Ooh. So, let's see where it could have broke. Be bigger than this. Repeat this until tightest cluster is the same. Oh, maybe I have to do these separately. Yeah. I probably have to do these separately. So in one step I find the tightest cluster, and the other step I find the emptiest void. Huh. Oh, I swear this should work though. I'm confused. I guess we'll do it separately. So comment this out. Find the min value first. Just going to comment all of this out. Set the min value to 1. Recompute the energy. Then we'll do the same thing here, but we'll compute the max value instead of the min. And we remove the energy there. So actually, if this was equal to the largest void, then we're done. All right, let's see if that works now. Okay, so also I think if JavaScript web workers have an error, they don't output any exceptions to the console. Show an error handling. Oh, on error. You need to add an on error handler. There's no error. What? What even? On error equals function event. No. Oh. Oh, this type of isn't returning true. Type of new uint8 array is object. Oh no. JavaScript type of is stupid. Why doesn't it say uint8 array? JavaScript typed of type array. How the fuck does type of not work with type array? What the fuck? Literally, the object with a type in JavaScript doesn't work with type of. Oh my god. JavaScript. Look at this, just for checking. Oh god. Yeah, you gotta check the constructor. Constructor. Let's do this in console first. Test A equals new uint8 array. Test A dot constructor equals uint8 array. True. uint16 array. False. Okay. Wait, why did it print out JavaScript is the kid in the corner of the class that eats glue? It didn't even make it to class, man. JavaScript is the one that doesn't go to school. Just does its own thing. Alright, so this seems to still not be working because it's outputting the array right there. So for whatever reason, this actually isn't returning true. What the hell? Let me try something. Dot constructor equals uint8 array. False. What? Why is this happening? Function number. Wait. Still doesn't make sense. Why is this number returning true? Or why is uint8 array returning false here? What? It's not. It's just still outputting the progress for some reason. Oh, I didn't have an else here. I'm an idiot. I just forgot else. That explains a lot. Alright, let's try. Copy image. This is supposed to be a blue noise sample pattern. Seems alright, but you know what? I think the Poisson disk is actually better. I think the Poisson disk is actually better than that. Like, let's see how that compares to just not even generating it. It looks basically the same. It looks basically the same. So I guess I'll try both. Yes, they're both scattered dots, can confirm. I'm looking for evenly distant points. And it almost seems like this one with the tightest void and everything doesn't actually have the best. So I'm going to skip this at the beginning because it seems like it's actually not needed. Not being annoying, it's a that's a legit comment. It is a bunch of scattered dots. Is it you or is it just me? Is it hard to read the text on this? Like this gray on white is actually getting hard on my eyes to read on this article here. I'm almost thinking of just copying. Doesn't look bad to me. It must just be me then. I'm going to copy it over here so it's easier to read. Actually, that makes it harder to read. I'm an idiot. All right, now that we have the initial binary pattern, we have to give a rank to each point, find the tightest cluster and remove it. The rank for that pixel you just removed is the number of ones left in the binary pattern. Continue this until you run out of points. Right. The rank for that pixel you just removed is the number of ones in the binary pattern. Wait, the number of ones left in the binary pattern. Oh shit, I have to count the number of ones in the binary pattern. Oh no. Actually, if I don't do this first step, then I can be confident that the initial number of dots is going to be width divided by 3 and height divided by 3 times each other. So that's cool. The rank for that pixel is the number of ones left in the binary pattern. So I'm going to need an array for ranks. Binary energy rank. Rank equals new uint32 array. Total size. All right, so now we repeat this until we remove all the points. So we need our number of points, which will be math.floor width divided by 3 plus 1, and then endpoint times endpoint, while endpoint minus minus does not equal 0. Here we go. So now we do the same thing, find the tightest cluster. Remove it. And And then we also have to set the rank equals n points left. All right, phase 2 resets back to the prototype binary pattern. Oh. So I need to save a version, a buffer for the energy. Yeah. And probably a buffer for the binary into energy 2. bin2 dot equals new uint8 array. It's a copy of that. Energy 2 equals new float. Hey, said who? Energy 2 is a copy of the energy float 32 array. All right, so now once this is done, I flipped around said who, and I'm actually generating this in JavaScript because I figured out the way it works. You have to basically add and remove one pixel at a time. It would not work well in GLSL, since like GLSL is all about batching things together. So I'm doing it in a web worker in JavaScript. So it's going to take a while to generate, but you know what? Yeah, blue noise. Perfect blue noise. As far as I'm aware, this void and cluster is the only method for generating actual perfect blue noise. So now that I've ranked these and removed them, the next step is reset back to the prototype. Wait. The current binary pattern is called the prototype. All right. I need to read about A star pathfinding. Oh man, pathfinding is goddamn complicated. There's like so many pros and cons when it comes to pathfinding of like trading off between performance and accuracy. I think there's another one now that's like D star, I think it might be called. Anyways, I reset the binary pattern to what I stored in this buffer here. I reset the energy to go along with it. Now, instead of removing the tightest clusters, I find the largest void and insert ones. So that's very similar to this. Maybe I'll do this in a for loop instead. So that way I save this endpoints variable. And then here I can just do endpoints minus I minus 1. Let me read this again. Find the largest, insert 1. The rank is the number of ones before you added it. The pixel is the number of ones before you added it. Huh. So this is actually going to be difficult because I don't actually just need to loop over the current number of points. I need to loop over the number of empty points. And I have to continue until half of the binary pattern is ones. Okay. All right. So I need to mark a halfway point. So first of all, total points is equal to the current endpoints. Then I need to go target points, or half points, which will be halfway. Half of them covered would be width times width divided by 2. So I equals total points until it equals half points. So now we need to find the emptiest void. That's the lowest energy. Oh, this is actually wrong, I think. If V bigger than, yeah, that's finding the max. Oh, I messed that up. Okay, that's correct. Move it, update energy, add 1, and update energy. I should also add a comment for rank is number of pixels left. Rank is number of rank is number of ones. Thing is, A star looks super slow. Yeah, that's what I was saying is like, I actually don't know a pathfinding method that's just like quick and fast and easy. It's like always trade-offs between either doing it slow and accurate or fast and rough. Add 1. Update energy. Energy, rank is number of ones. This is such an interesting algorithm, just the way this works. Basically mapping out the voids and clusters. So then the rank is just I here, I believe. Alright, so that should repeat until half the binary pattern is ones. Now it's phase 3, the fucking last step. Oh yeah, hopefully we're actually on the way. Phase 3 continues adding progressive sample points. I'm gonna feel as bad, man, if I do all this and then I do step 3 and it doesn't work. that's gonna be good. It's gonna be a good troll. Alright. Continues adding points until the entire binary pattern is made up of ones. It does this by reversing the meaning of zeros and ones in the energy calculation and does this in a loop. Find the largest cluster of zeros and insert ones. Ah, oh, fuck, I need to switch around the energy pattern now. Oh, this is going to be expensive because you need to recompute. Going to need to completely recompute the energy values, I think. Yeah, because it needs to actually calculate the zeros, and right now all it's doing is calculating the ones. I literally need to recalculate it. Compute zero energy. So now instead of checking if it's 1, I checking if it's 0 and skipping, I check if it's 1 and skip it. So compute zero energy. Find the largest cluster zeros, insert a 1. The rank of the pixel you just added is the number of ones in the binary. Okay, so this is basically continuing on exactly where this left off, but filling in the rest. Instead of going all the way to half, it goes to the full. So for var I, total points equals half points. I bigger equals total points. I bigger than total size. So now it loops through the rest. Largest cluster of zeros. So I think this is the same as the tightest cluster where you find the max value. So I'm going to copy this, redo the loop. Zeros. Insert 1, rank. Okay, and because this is now 1, I actually remove the energy. Alright, so now, finalizing the texture. To make a blue noise texture, you need to turn ranks into pixel values. So this is the last step here. So now all I do hopefully this works. Bigger than total size. I'm just going to store the result in binary. So the scale is going to be rank. Just set this up. Post message bin All right, and I am not outputting any sort of counter now, so this is going to just take a while, I think. I'm just going to output basic progress. So like this initial binary pattern will be 5% done. This will be 40% done. This will be 80% done. Or 75. This will be 99. All right. So now to convert these ranks, I need to multiply by 255 and divide by total size, I believe. Because total size. All right, see how this works. 99% done. It didn't work. Oh boy. This is all right. Let's see what's going wrong. It computed very quickly as well, which isn't really a good thing, I don't think. Rankings, number of points. Try removing this. So it's got like a single white point. What is it doing? Bin I equals rank I times 255 divided by total size. This, I don't know why this isn't working. Or at least why it isn't outputting more white than gray. Maybe it's because I skipped this initial binary pattern step. Let me just check something as well. I'm pretty sure if you can create a uint8 array with another uint8 array. Yeah, you can. So it's not this. This is initializing, correct? Endpoints equals width divided by 3. You could use my integers library. I just want it to be as fast as possible with int32s. Oh, maybe it's because as well as doing I here, I'm doing I right here. C has got me in this really bad habit where you can write 2 I loops in another, and C will automatically choose the local closest one. Okay. There we go. That's why you should use let instead of var. Okay, so that's a lot better. That pattern right there is good. Yeah, that is why I should use let. But I can't remember. I'm too used to writing var at this point. So let's try doing this step by step. So this should be with half the values at 1. Let me see what it looks like. I feel like not half the values are 1. Yeah, half the values are definitely not 1. All these giant gaps here, there's definitely not half 1s here. And you can probably see too if you do a Gaussian blur and you average it out. It doesn't average out to gray, it averages out to like, or it doesn't average to 0.5, it averages to like, it's better. But still, this is supposed to go to half the points. Oh. This is checking the highest energy when it's supposed to check the lowest energy. No, that's still not even close to half. So what's supposed to happen is right here, it runs through and removes all the points, so it's only going to be ranking like 10% of them. So it makes sense that with the first step, it looks this, there's only these few points. But after running this step, maybe it's because I'm not flooring this. I don't know. Let me see. 16 divided by 2. And the current total points, endpoints, what would it be? 16 divided by 3. 6 times 6. So it would be 36 to 128 here. There's no reason why it shouldn't be filling these in. I wonder if it's not even running this array. No, I think it is. That looks different. Oh, I also need to add a check that checks if it's already generating, and if it is, doesn't let you run it more than once. Huh. It confuses me though. It seems like commenting this out does nothing to the pattern, which says to me that this isn't actually updating any of the ranks for some reason. For some reason or another, this isn't looping. So what it makes me think. So 36 compared to 16 times 16 divided by 2. It should be yeah, I don't know. I must be making some mistake somewhere here. Be bigger than, so this is find the emptiest. MV, MI. I would think that this error is literally just me writing some variable name wrong somewhere. Maybe it's the energy.set or binary.set here. Sets multiple values. Nope, that's working fine as well. I guess it could be that MI is setting variables that already are set, or ranks that are already set. So just dividing by t size should make it black. Oh. Oh. There's a dot here where it isn't black. It's fully white. So for this to be fully white, this rank value would need to be higher than the total size, which I'm setting the rank values to the iterators here, and it should never be higher. Unless that -1 right there is making it negative. No, there's still that point there. Huh. What the heck? Let me try something. This is supposed to initialize to 0, but I'll try filling it with 0. No, it's still... Oh, okay, what is going wrong here? Alright, let's try removing this. So if you see in my loop here, rank is being set to endpoints minus I, and endpoints is the size, the width divided by 3 and then squared, so it's like the total area of the width divided by 3. So at most, this rank should be like a fourth of the total size, which is width times width. Right here, width times width. So then down here, we're dividing the rank by the total size, and somehow, oh, it's all black. So that means that the error, that white pixel, is showing up from somewhere right here. For whatever reason, this loop right here is sending I above the total size. Which doesn't make any sense because it's the total size divided by 2. Oh my god, it does. I'm an idiot. How did I not miss this? How did I miss this? So I fixed the I loop in there, and then I never fixed it down here. Oh god, I gotta start using let, man. Oh my god. There we go, it's all black. That's what I was looking for. So now times 255. Oh my god, it's actually looking like a blue noise pattern. Oh, it's working! It's working! It's like a blue noise pattern, but it's all white, which is not good. It's supposed to be gray. Hold on, let me scan that with my phone. It's basically the idea behind QR codes. Alright, so let me try without times 255. So it's still outputting values. Oh, I had this code here that's checking if it's 1 or 0 and just outputting 1 or 0, multiplying it by 255 again. That explains it. There's the beginning of the blue noise pattern. So I'm thinking this is multiplied by 255, and this is set to I. You know what? Let's try adding the last step, and then we'll decide if it's good or bad. I'm going to make it smaller as well. Yeah, so that's wrong, and it's wrong because I still have that exact same error in my loop. I'm a fucking idiot, you know that? I had this error because I copy and pasted the same code that I wrote 3 times with the same error, and then I fixed the error in one of the loops, and I forgot to fix it in all of the loops. God damn it. Well, it's still broken, so I must have done something wrong. Also, these artifacts around the edge, I need to make the energy equation tiling. Can you put the loops in a function since it's the same code? It's not exactly the same code. It's the code with a comparison operator switched and this remove and add energy switched. And I just want to reduce function calls as well to make it as fast as possible. So at this point, I actually think it looks better without this. So also looking at this, I think the ranking, let me read the end of this again. Your output is 8 bits. You need to turn your ranks into 0 to n. You want to do this by multiplying. Number of pixels is the number of ranks there are. That's what I thought. Multiplying by 256 and divide by the number of pixels. That's exactly what I'm doing. Except I'm multiplying by 255 instead of 256. Huh. Alright. Let's reread this part, because apparently it's wrong. Continues adding sample points until the entire binary pattern is made up of ones. Does this by reversing the meaning of zeros and ones. Hold on. Just to make sure this is working properly, I'm going to have this output. Oh, so this is supposed to be add the check here. This should output half as ones. Yeah, that looks right. Half of the values are ones. Okay, so I know that part is working properly. So if I had to guess, it's either something with this compute zero energy function, reversing the meanings of zeros and ones in the energy calculation. Find the largest cluster of zeros. E times distance squared. You're looking at how much energy specific pixel S contributes to pixel P. Reversing the meaning of zeros and ones. I'm pretty sure I already did that. Instead of checking 0, I check 1 right here. So it skips all the 1s. So instead the zeros contribute most energy. The rank for the pixel you just added is the number of 1s in the binary pattern before you added it. Continue until the entire binary pattern is 1s. Alright, let's make sure this is working. So it should be a completely white image after doing this. It's not completely white, so something is going wrong here. Total points equals half points. So yeah, do half points. I forgot to replace I with K here. That would explain it. It's still not all white though. Binary equals 1. Move energy. So even without this, it basically looks the same, right? Yeah, it does. Just making sure. Yeah, so it does not seem to add any extra white values when it's doing this. So something is going wrong here. Insert a 1. The rank is the pixel. It is. So this should go through and fill up unless my energy, so yeah, the thing that would fail here is the compute energy function. If something is wrong here, it's with the compute energy function. Equals 0 equals 1 does not equal 0. We'll try that. Nope. Compute reverse energy for clusters of zeros. Oh, so I need to change this remove energy function, I think, too. So when I set a value to 1, it removes energy from here. So I am removing energy. Yeah, actually, I don't know why this isn't working. Remove energy minus equals sigma. Oh, so I keep seeing this. What is CCVD? Constrained Voronoi diagrams. Oh, okay. Progressive points until all are ones. Ooh, I can't believe I'm stuck on the last step. This is like, I guess I could do a simple check that's like if points bigger than total size. No, I know it's doing this. K, K, K. Let me try something. If bin mi is already equal to 1, post message shit and return. Shit, percent done. Okay, so there is an error happening. For whatever reason, the energy calculation is wrong. It's calculating. It should be selecting something with the most 0 here. Largest cluster of zeros and insert 1. Yeah, so the odds of this not being on a 1, like the odds of this not being on a 0 is super small. Oh, I'm an idiot. This is initialized with 1e8 just like this, but it's comparing min instead of max, so it's supposed to start at 0. Still shit percent done. That's... Huh. Huh. Alright, seems to be making no difference. Hmm. Alright, what if instead of breaking out here... Oh yeah, it sets more to white there, but it should set each one to 1. So you're liking Sergeant Frog? I haven't gotten back to watching it yet. Yeah, I haven't. I am really liking. I really liked the first 2 episodes. There must be something wrong with my energy calculation. Like it's... I don't know though. Maybe I'll try doing this first step. Generate initial blue noise sample pattern. Nope, didn't change a thing. Yeah, so finding the largest cluster of zeros, it should be landing on a 0 right now, but for some reason it's landing on a 1. Let me output the max value. Well, you know what? Maybe it's like not a number error or something. Shit. At 9.5, no, so it's not that. Reversing the meaning of zeros and ones. I think this is the key part I'm missing out on, reversing the meaning of zeros and ones in the energy calculation. because all I'm doing is changing the if statement here, but I feel like there might actually be a way you implement this in the energy calculation. Maybe I only calculate it here if the binary value is equal to 0, and that way it can only find values that are 0. No. It got farther, but it still found a value that's 0. And that's that's actually incorrect. Because when it computes the 0 energy here, any values that are 0, oh wait, instead of removing the energy here, I also probably want to set the energy of this value to 0 so it never gets selected again. Oh, it's so close. It's almost all white. What are those few points? What are those few points? What are these? What are these? Let me think about this. This is going into negative energy. So I'm actually going to make this recursive. And when this finds 1, so if value smaller than equal to 0, we're done. Now this should repeat until it's all white. Oh my god, it did. Okay, now for the final test. We output the ranks, and hopefully the ranks actually show us a blue noise pattern. Oh, it's gray. Alright, so it looks kind of like a blue noise pattern. But I just realized why it's gray. It's because I'm not accurately counting the number of points right here. Okay, so I'm actually going to check some of my math right here, because for all I know, this actually isn't setting half of the points to 1. So I'm going to count the number of points. Out of half points, or out of total size. So this should let me know. One sec. Actually, I'm gonna reset this. Oh, apparently it's bugged. Fantastic. Oh, man. I guess I... What the hell? Did anyone else just see that black line across my screen after I closed it? Man, Windows is doing some weird shit after the update. Okay. So now this will output the number of points, which should be half. Count 1747 out of 496. Nope. That is wrong. That is wrong. Is it random? It is random. Huh. Let's see how many points it starts with. Because it should start with n points. So this explains why it wasn't adding up before. 484 out of 484, so that's right. So it is initializing to the predicted amount. Oh, this must be already setting it to one that's 1. So if bin mi equals 1, self.postMessage shit. Shit, yeah, that's what I thought. Okay, I know what's going wrong here. I know what's going wrong here. Let's also check right here. I think I know what's going wrong. Damn. So it is. Okay, so my energy calculations are wrong. Or something is up with them because finding the tightest cluster, the highest energy, so originally I had this code that was like if binary value equals 0 or equals 1, then calculate the energy. But then my issue was when we go to this next step to find the emptiest void to put a 1 there, we need to ignore it in the energy. So either instead of doing this, I can do that for the 0 energy part, I believe. For this part, though, I believe what I should do is, when it's checking if it's finding the tightest cluster, if the binary version of this, since it's trying to find a place to reset to 0, if it finds a place that's 0, it skips it. And in this part, if it finds part that's 0, it does it because it needs to place a 1 there. So now this will be a success if this doesn't output shit or damn. No, and it works perfectly actually. As you can see, it goes to half of the size, which is what we wanted before. Awesome. So now we can go back to computing the zero energy. We don't need to do a while loop because we know for a fact that it's going to be 2048 to 4096, or basically half the size. We have our half points variable here, goes up to t size. Just to make sure, we're going to output our white pattern. Okay, that's black. Whatever, we'll just output the blue noise. Fucking Pog! We got blue noise! Holy shit! Fuck yeah, we did it! This is a blue noise texture. It's not tiling, as you can probably see by the edges here. But, oh man. So now, okay. So now the next step is going to be setting up a histogram and threshold test to make sure that it actually performs. Oh my god, I'm so happy with this. So let's see, how long does it take to generate a 256 by 256? It's not even that slow, I don't think, either. I also got to add a proper proper loading thing for this. So yeah, it's going to take a while to generate a 256 by 256, but that's to be expected. Tons of operations are being done. Anyways, I'm so happy to have this. This is going to be such a useful tool. Oh man, I have not eaten breakfast yet today. I am fucking starving. I fucked up. I work way worse when I don't eat. This probably would have went way quicker if I actually took care of myself, but you know how it goes. Anyways, now that we have this done, we can work on polishing it next time. Like I said, doing histogram tests and threshold tests to make sure the blue noise is actually perfect. You can't even see my fingers, but perfect. And then, polish it up, release the source code, all that stuff. It's going to be great. Anyways, that was the end of the stream for now. I'm just happy to get this algorithm working. If you're interested in any of this stuff, I'll be continuing talking about it in the Discord. You can find the link to that in there or off to the side in chat. The bot posts the links in chat all the time. But yeah, thanks for watching. Thanks for figuring out blue noise with me. I'll see you guys around either tonight for some Borderlands, or I might continue this afternoon polishing the blue noise. Either way, there'll be another stream today. See you guys around.